This video is going to look at the relationship between moles and mass. Now, the mass of substance is to do with how heavy it is, how much it weighs. The number of moles of a substance is to do with how many particles there are in it, how many atoms or how many molecules. I introduced about moles in the last video, which is about the Avogadro constant. And we said that a mole is just like a pair is 2 and just like a dozen is 12, the mole is a number. And a mole is this massive number here, which is roughly 600,000 billion, or in standard form, 6.02 times 10 to the power of 23. What I didn't explain in that video is why do we use that number? Why is that the Avogadro constant? Why is that what we define a mole as? And the answer is, because the mole is defined as that number of particles, the relative atomic mass of an atom, or relative formula mass of a compound, is related to the mass of a mole of it. So I'm going to use a couple of examples so you can see what I mean. Here's helium. Its relative atomic mass is 4. And we know that that is because each atom has got 2 protons and 2 neutrons in the nucleus. But if we had this number, 6.02 times 10 to the power of 23, of helium atoms, it would weigh 4 grams. Or, if we took sodium as an example, the relative atomic mass of sodium is 23, and that's because it's got 11 protons and, on average, 12 neutrons in the nucleus. But if we had this number, 6.02 times 10 to the power of 23, of sodium atoms, it would weigh 23 grams. So that's why we use this number. It relates the relative atomic mass, or the relative formula mass, of a substance to how much 1 mole of it weighs in grams. And that means that we can relate moles and mass using an equation, using a formula. So it is this: moles, the number of moles of a substance, is found by the mass of the substance divided by the relative formula mass, or the relative atomic mass if it's just an element that we're dealing with. If you like using formula triangles, we can put that into a triangle. So it'd have mass on the top, and then it'd have moles and relative formula mass on the bottom. So we divide those and we times those. Just going to put units in as well. We know that mass in chemistry, we measure the mass in grams. Number of moles, we just shorten it slightly when we write the units, and we say that it's a mole. The relative formula mass, therefore, tells us number of grams per mole. The units for this would be grams divided by moles, and we can show that as grams/mole. And I explained that in the video where I talked about relative formula mass. I said that sometimes we give units for relative formula mass and we say that it's number of grams per mole. This is why. It's because of this relationship, this equation here. Okay, I'm going to go through some worked examples of how to use this formula, this relationship, to solve some problems. The most common one is where we're trying to find the mass, the moles, sorry. So I might be told that I've got 10 grams of caffeine and asked to work out how many moles of caffeine have I therefore got. And that's because I can work out the mass of something by weighing it. I can know the relative formula mass by using a periodic table, so I can then work out the number of moles by doing this sum. So on the video where I talked about relative formula mass, I used caffeine as an example, and we worked out that the relative formula mass of caffeine is 194. So I'll just make a note of that. Okay, so first step for a calculation, we write down the formula. So I'm going to write moles is mass divided by relative formula mass. Then I put in my numbers, so 10.0 grams divided by 194 is the relative formula mass. And I did that earlier, I got that is 0.0 0.515. And the reason I've quoted it to that number of significant figures, because I've rounded it to get that, is because in the question I was told that I've got the mass is 10.0, so there's 3 significant figures there, and I've got the relative formula mass to 3 significant figures as well. So that's why I'm giving the answer to 3 significant figures. Last thing, units. The units for moles, I write MOL, mole. Okay, so that's the most common kind of question you do, but you might also be asked to work out what the mass of something is if you're told the number of moles and the relative formula mass. So if I was told I've got 2 moles of water, first of all, what's the relative formula mass? I use water as an example again. We found out that the relative formula mass is 18 grams per mole. So let's make a note of that first. Okay, let's go through. So this time, if I'm asked to work out the mass, I've got to do moles times relative formula mass. Then I put in my numbers. So number of moles is 2. Relative formula mass is 18. I put my answer, which is 36 in this case, and then my units is mass, so the units is grams. Okay. Last kind of question is a little bit outside the box. It's a bit different, a bit unusual, but I could work out the relative formula mass of something to identify what it is. So I could be asked a question where I'm told I've got 0.787 moles of a metal, and I've weighed it and its mass is 50 grams. What metal is it? Now, if I was given that question in an exam, what I would do is I would see that I've been told the moles and the grams, so I can work out the relative formula mass by doing grams divided by moles. And if I know relative formula mass, then I can just use a periodic table to find which metal it is. Okay, so again, I'm going to write down the formula first. So relative formula mass is mass divided by moles. Then I put in my numbers. So the mass is 50.0, and the number of moles is 0.787. And then I write my answer, which I find my answer is 63.5. Again, I've given it to 3 significant figures because I was told the mass to 3 significant figures and the number of moles. And the units for relative formula mass, if I need to give them, is grams per mole. Now I know that, because relative formula mass is just the relative atomic mass for the metal. I'm going to look for which metal has got the relative atomic mass of 63.5. And I find that it is copper. So the metal is copper. So there's 3 worked examples of how we can use this equation, this relationship, to work out either the moles, the mass, or relative formula mass. It's one to remember. This is arguably the most important equation or formula in chemistry.